Hey y'all, this is Unit 3 of AP Chemistry. The first thing you have to know before entering this unit is that intermolecular forces are attractive or repulsive forces between molecules, while intramolecular forces are bonds within a molecule. Covalent and ionic bonds are intramolecular forces. And there are three types of intermolecular forces: London, dispersion, dipole, and the strongest hydrogen bonds. London dispersion forces are the weakest. And you have to know that these forces are in every molecule. They are known as instantaneous or temporary dipoles because they are caused by the temporary and random fluctuations in electron distribution around a molecule. So basically, the uneven distribution results in an instantaneous dipole, leading to a short-lived attraction between a neighboring molecule. Electrons are in constant motion, so LDFs happen all the time. Now listen, when you see a nonpolar molecule like methane, CH4, know that these molecules only have LDFs. The strength of LDFs can increase depending on the size of a molecule, can sometimes outweigh the strength of a molecule with dipole-dipole forces and even hydrogen bonds. Now this is because with more electrons that come with more atoms in a molecule, the stronger the instantaneous dipole because of a polarizable electron cloud. Polarizability is the ability of an atom to form a dipole. Okay, now moving on to dipole forces. Basically, all polar molecules will have these, and basically, the more polar the molecule, the stronger the dipole forces and the decreased distance between the dipoles. If you're sitting there confused as to what a dipole is, just know that dipoles are attracted because of one positive end of a molecule is attracted to the negative end. All right, now let's review hydrogen bonds. These are the strongest type of intermolecular force, and these happen only when a hydrogen atom in a molecule is bonded to a fluorine, oxygen, or nitrogen atom. Please remember this as the strongest force, and that it's only those three molecules. There's also one more type of intermolecular force that is very worth noting for the AP Chem exam. This showed up when I took my AP exam, y'all, so listen up. It's called ion dipole forces, and they arise from the attraction between a fully charged ion like sodium and a partial charge from a dipole. Now, some important things to note: ion dipole forces are stronger than regular dipole forces because ion dipole forces have a fully charged ion, while dipole forces just have partial charges. A common example of ion dipole forces is sodium chloride in water, where the sodium turns positively charged and attracts to the negatively charged oxygen in the polar water molecule. All right. To cap off this topic, let's review this chart of characteristics determined by intermolecular forces. First, gases have weak intermolecular forces while solids have strong forces. Substances with weak LDFs are found in the gas phase at STP. For boiling and melting points, a higher boiling point means the molecule has stronger IMFs. For example, a molecule with a boiling point of 100 degrees Celsius will have stronger IMFs than a molecule with a boiling point of 50 degrees Celsius. Next, volatility is the tendency of a substance to vaporize or quickly transition to the gas phase. Essentially, the more volatile, the weaker the IMFs. Viscosity is the measure of a fluid's resistance to flow. So if a fluid acts like honey, then it has stronger IMFs than a fluid that flows like water. For surface tension, liquids with high surface tension have strong IMFs. Now, surface tension is sort of a difficult concept to grasp. So here's a definition: the force acting on the surface of a liquid tending to minimize the area of a surface. It is also known as the interfacial force or interfacial tension. To relate this to IMFs, water has high surface tension because of the hydrogen bonds between the water molecules at the surface. All you need to know for this course, though, is that higher surface tension equals stronger IMFs. Finally, vapor pressure is lower with stronger IMFs. Don't get this confused with volatility. Volatility is how easy a substance turns into a gas, while vapor pressure is the quantitative measure of this pressure that the gas creates. All right, y'all, that's about it for topic 3.1, intermolecular forces in AP Chemistry. Be sure to check out more science-related stuff through the Polymer Club website. I hope this video helps. More videos coming soon. LeBron out. Peace.
Little girl, she told you she celibate, but she told me I could nail her shit.